All right, in this lesson we are looking at how to solve a system of linear equations using a method known as elimination. So we've looked at solving by graphing, we've looked at solving by substitution. I think elimination is the most powerful of the three methods because there are some systems of equations where it's really hard to solve by substitution, and a lot of them that it's really hard to solve by graphing, but elimination will let you solve, I think, even the trickiest. It's this method that you're going to use even on the trickiest problems. So let's just take a look here and see how it works. So the idea here is when we use elimination, we are adding or subtracting the two equations that we have in our system of equations. Okay? And the goal when we're doing this adding or subtracting is to eliminate one of the variables. That's why we call it elimination. Now, this elimination only works if one of our variables has the same or the opposite coefficient in both of these equations. So I've got this example here, negative 3x plus 4y equals 7, 3x plus y equals negative 2, and I'm either going to add or subtract these two equations. How do I know if I'm going to add or subtract? Well, when I look at them, I got a negative 3x here, and I've got a positive 3x here. Those two things are going to cancel out if I add them together. So I'm going to add these two equations. And usually when we do this adding, we rearrange our equations so that they're one on top of each other. So I'm just going to rewrite that first equation, and then I'm going to put the second equation underneath it. And when I do this, I'm matching up the like terms, kind of like when we did when we were adding polynomials or subtracting polynomials. And now I'm going to add these two equations. So my negative 3x plus my 3x, these are going to cancel each other out. And I've eliminated x from this new equation. Then I have to add my y terms. So 4y plus 1y is going to give me 5y's. I still have an equal sign here. And 7 plus negative 2 on the right-hand side gives me a 5. Without x in there, because it's been eliminated, it's now pretty easy to solve for y. I'm just going to divide by 5 on both sides, and y is equal to 1. So we're halfway to our solution. We know that y is equal to 1. Now, just like we did with substitution, we can come back and we can take one of our original equations here, 3x plus y equals negative 2, and we can substitute this value into this equation. So if y is equal to 1, we get 3y plus 1 equals negative 2, or sorry, 3x plus 1 equals negative 2. I can subtract 1 from both sides. 3x is negative 3. Divide both sides by x. Divide both sides by 3, and x is going to be negative 1. So our solution here is x equals negative 1, y equals 1, or the point negative 1, 1. Okay? So the key was getting these x terms here to have the same coefficient, or in this case the opposite coefficient, so we could eliminate x and solve for y. Now, sometimes we have to do a little bit of work on one or both of our equations because the coefficients don't match up. So here I've got 3x plus 2y equals 14 and 5x minus y equals 6. So I don't see any coefficients in there that match up. But I can take this equation here and I can multiply it by 2. And when I multiply by 2, I'm going to multiply every single one of these terms by 2. So taking this 5x and multiplying by 2 gives me a 10x. The negative 2y times 2 becomes a negative 2y. And the 6 times 2 becomes a 14. Doing that means that I now have a positive 2y there and a negative 2y there. So if I add my two equations, those y's are going to cancel, those y terms will cancel each other out. So 3x plus 10x is 13x. Obviously, 2y and negative 2y cancel each other out. That was the whole point. And then 14 plus 12 is 26. Divide both sides by 13, and we get that x is equal to 2. Once we have x equals 2, we can come back to our original equation here. 5x minus y equals 6. We can sub in 2 for x. 10 minus y equals 6. Negative y, subtracting 10 from both sides, is negative 4. So y is going to equal 4. So we've got our solution here, x equals 2, y equals 4, or the ordered pair 2, 4. So if the coefficients don't match, we can multiply one equation, or as we're going to see in the next example, we can multiply both equations to get those coefficients to match up. So here, as I'm saying, sometimes we have to multiply both equations. So I've got 3 equals 5x plus 2y, 5 equals 2x minus 7y, and I want to get coefficients between that top equation and that bottom equation to match up. What I can do here is I notice that, let's say I want to get the x's to match up. Okay, down here I've got a coefficient of 2. So I can multiply this top equation by 2. 3 times 2 is going to give me 6 equals negative 5x times 2 is negative 10x. 2y times 2 is going to give me 4y. I've got a negative 5 up here, so I can multiply this equation down here by negative 5. 5 times negative 5 is negative 25, equal sign. 10 times negative 5 is negative 10x. Negative 7y times negative 5 is positive 35y. Okay? So basically I'm just multiplying by the term that I saw on x in the other equation. And if I do that, we see that, hey, we get a negative 10x here, we get a negative 10x here. Because those two coefficients are the same, we are going to need to subtract our two equations, right? Negative 10x minus negative 10x, so negative 10x plus 10x are going to cancel each other out. So we have to make sure here that we're subtracting everything. 6 minus negative 25 is 6 plus 25, or 31. Our 10x's are going to cancel out. Negative 10x minus negative 10x cancels out. And then we've got 4y minus 35y is going to give me negative 31y, doing that subtraction. If I divide both sides by negative 31, I get y is equal to negative 1. I'm halfway there. So we multiplied one or both of the equations to get our coefficients to match up. Then we had to, in this case, we had to subtract the equations to eliminate a variable, and we solved for the remaining variable. Now we just have to go back to one of our original equations here, substitute, and solve for the other variable. So we'll use equation number 2 here. 5 equals 2x minus 7, but instead of y, we're going to put in a negative 1. From y equals negative 1. 5 equals 2x, negative 1, no, sorry, negative 7 times negative 1 is going to give us a positive 7. If we subtract 7 from both sides, we'll get negative 2 equals 2x, and divide both sides by 2, x equals negative 1. So there's our solution, x equals negative 1, y equals negative 1, or the point negative 1, negative 1. Okay. So the key to this one was getting those two coefficients to match up by multiplying both equations by an appropriate number. All right, so here's a good one to try on your own. We got x minus y equals 2, 2x plus y equals 14. Pause the video here, try this question, see how it goes, and then start the video again to check your solution. Okay, what would I do for this one here? I might take this first equation here and multiply it by 3, because that'll get my coefficient on y to match up. So multiplying that one by 3 is going to give us, just putting that over here, x times 3 is 3x, negative y times 3, negative 3y, 3 times 2 is going to be 6. So I've got 2x plus 3y equals 14, 3x minus 3y equals 6. I'm going to add these two equations together because that'll cancel out those y terms. 2x plus 3x is 5x. Obviously, our y terms cancel out. 14 plus 6 is 20. Dividing by 5, x is going to be equal to 4. If x is equal to 4, we can sub that into our original equation here. 4 minus y equals 2. Subtract 4 from both sides. 2 minus 4 is negative 2. So y equals 2. So there's our solution. Y equals 2, x equals 4, or the point 42. Now, in this one, you might have chosen to eliminate x instead of eliminating y. You should still get the exact same answer. All right. All right, finally, a trickier one here. We've got some fractions. What do we do when we have fractions? Well, the fractions are causing a problem, so we want to get rid of the fractions first. And we can do this by multiplying through by a common denominator of these fractions. So in my first equation here, I've got a 3 and a 2. My common denominator would be a 6. So I want to multiply this equation by 6 on both sides. Every term gets multiplied by 6. So 6x divided by 3 is going to give me 2x. 6y divided by 2 is going to give me negative 3y. And then on the other side, I'm going to have negative 18. For my second equation, my common denominator would be a 30. So I'm going to multiply by 30. Okay, remembering to multiply all terms by 30 here. So 30x divided by 6 is going to give me 5x. 30y divided by 5 is going to give me 6y. And 3 times 30 gives me 90. Okay. Once I've gotten rid of the fractions, now I can start trying to think about how I'm going to solve this using elimination. And I think the easiest thing to do for elimination here is to multiply that top equation by 2 to eliminate y. So I'm just going to bring this down here. 2x times 2 is 4x, and negative 3y times 2 is negative 6y. Negative 18 times 2 is negative 36. Now I'm going to add 9x, of course the 6y and the negative 6y cancel, and 90 minus 36 is going to give me 54. Divide both sides by 9, and x is equal to 6. Now, I wouldn't probably go back to one of my original equations here to solve for y. I would probably go to this equation right here and sub in my value for x. So 2 times x minus 3y equals negative 18. Let me sub that in over there. 12 minus 3y equals negative 18. Negative 3y equals, let's see, negative 18 minus 12 is going to be negative 30. And dividing both sides by negative 3, we get y equals 10. So there's our solution, x equals 6, y equals 10, or the point 6, 10.